I am sitting at a front of house desk. And there's Felix. Ne, Felix. So I'm sitting at Lerner Acoustic AG in the bottom part of Switzerland, and we have set up a front of house for a video conference. And we are using a wireless system as well as a streaming system, and we are also using a mixing console for everything audio and visual for a video conference or for a conference in general. And this video is going to walk you through the process of how we set up things here. So yeah, let's get to that.
Here we have our Shure wireless system. In the rack, we have our Shure AD4D, which is 2 channels, and we have a controller on that side. At the bottom, we have a battery bank. In here, we have 2 batteries. Each of these are used to charge either a wireless microphone or a wireless transmitter. Over here on the patch bay, we have 2 XLRs out for each channel. And then we have 2 Ethernet ports for Dante, a power link, and a power con input. Now we can plug in the power con, which is already powered from the wall socket. And we have power to the whole device. Now, we have 2 channels. Channel 1 is over here, and channel 2 is over here for selection. In either of these channels, you can plug in a wireless microphone, like the Shure Beta 87C, or you could have something like a wireless transmitter, like this 81. If we take this 81 and open it up, you see the standard controls, and we can put a battery inside. The standard controls on this device are used to select different radio frequencies or any other settings on the device that is required. However, there is an easier way. And once it's inside, the switch is at the top, and we can turn on the device. At the moment, the device is not synced to the channel strip, so our next process is to go through the main menu and then sync the device. Here is the display of the device. If we go to the main menu of the device, we can see different configurations. Here we have the RF band, and you can scroll all the way down and see other parts of the menu as well. One important menu selection inside this device is the device audio setting. Here you can see our digital AES3, or the ability to connect to a Dante system. Aside from that, there are other options inside the menu, such as factory reset, user presets, device RF, or if you go back, we can see the channels with the different frequencies that they are connected to. If we select channel 1, we can go to the channel menu. Inside the channel menu, we'll have several of the same kind of functions. But for us, the most important things to look at is channel scan. Here we can either scan for the next available channel or the best available channel. However, there is a better way to do this. Considering we have 2 channels, it would actually be better if we did a group scan. The reason for this is because we are working with multiple microphones. So if we select group scan and go into it, it will tell us that in order to perform a group scan, we need to turn off all the transmitters. So we will turn this transmitter off, and then we'll start the group scan. What this does is that it will scan the entire radio frequency spectrum for the best available group that we can use for our microphones. Once the scan is complete, we can now go on to syncing our device. Here we have an infrared scanner as well as a monitor control. If we wish to scan a device, we will press the channel we wish to scan and press sync. On the inside of our wireless transmitter, we will then link them together. However, in this case, we have a sync failure. And the reason for this is because our receiver is not in the correct frequency band. The solution to this is to go into this RF band and then change it that it covers the entire frequency spectrum that we use. Therefore, it is now scanning all over that frequency band that we have available. Now we can sync again, and we have a successful sync. This is easily seen on the channel that we just synced, as the signal can now be seen coming in on the signal detection. There is, however, something we need to look at further. If we look at the signal on this device at the moment, it just dropped. And this is because I moved the device away from the transmitter. The reason this happens is because we have not plugged in our antenna. It's probably better to plug the antenna in first before you start doing anything else. These are the standard antenna that come with the Shure device. If we plug these in, we will get a signal that is increased. However, it is recommended that if you go over 30 meters, it is better to use antenna that are external to this device over a coaxial cable. This would be something like a Shure UA874 or equivalent. Okay, so here we have a type of conferencing system. Now, these vary from manufacturer to manufacturer, but in essence, they all work very similarly. This is the receiver box of a Shure MXCW. Now, these names are irrelevant mainly, but in essence, this is how this one works. We have the battery that will be plugged into the back. These batteries are usually loaded on an external station. However, the main process is the same. We plug in the battery into the slot at the back, which will give power to the device, which can last above 10 hours, which is perfectly long enough for any conference. Once the battery's in, the display of the device will turn on. And on the screen, it shows that it needs to be connected to the system receiver. But in the meantime, what we can do is look at the microphone. The microphone has a unique kind of USB-looking port, and this microphone, which is a gooseneck microphone, will be plugged into the device directly. Once the device is powered and the microphone's plugged in, we can now start to sync this device to the wireless receiver. But before that happens, what it's doing at the moment, it is scanning all around to see if it can connect to something. Once it scans, it will go green, as so. And then you'll be able to see the seat number and the logo on the screen. Now we have two devices. This one is showing one seat, and the other one is showing a different seat. And of course, you'll have more devices, all of which should have their own seat. For the receiver, we have multiple different components. This is the wireless receiver. This is the device that will share the signal from each device over a network, which is controlled by that netgear, over Ethernet cables into our mixer. If we look closely at this device, at the back, we will see an Ethernet port. This Ethernet port will be plugged into our netgear switch. To plug in the device, we will take an Ethernet cable. This one is a Cat6 cable, and we will unroll it, and we'll plug in the RJ45 connector into the device. And then take the rest of the cable and run it through the loop. Now that it is in place, we now need to connect the back panel. This is a road clip that we got externally, and we'll line up the clamp exactly to where they need to be and slide it in. Once it is in, it is now safe and secure, and your Ethernet cable will not fall out. On the other end of the Ethernet cable, this will not go directly into a laptop. This is because we need to use a switch. In this case, we're using the Netgear unmanaged switch, and the reason for this is because it uses PoE, or Power over Ethernet. The receiver does not use batteries, nor does it plug into a wall socket. It only receives power over the Ethernet cable. Once the device is plugged in, we will then take a second Ethernet cable and plug it into the same switch, and the other end of that RJ45 will go into our laptop. Our device now has power and is indicated by the two green LEDs on the right of the display. Now that we have power, we can connect this to our mixing desk and we can connect it to our computer for configuration. If we flip the device up, we can see two XLR ports, an in and an out. This is how we will connect our audio to our mixing desk. We have an analog in and we have an analog out. Now, of course, we want to use the analog out. So in this case, we will take our XLR cable. The female end will go into the male end, therefore sending an out signal. And we can flip it back up and set it to a good height where it's not obstructed or interfered by other objects. The other side of the XLR cable will be plugged into our mixing desk. At the moment, we have a laptop plugged in as well as the two channels from our wireless microphones. We can now plug in the wireless transmitter from our conference system into an available channel, and all the microphones that are synced to this device will go through that channel. At the moment, we have no output set up, and this is because we'll deal with this when we get to the amplification process, but keep in mind that channel 7 and 8 is usually reserved for our main outputs. Now, if we go back to our receiver, we have to keep something very important in mind. On the menu, when you scroll down, you'll see the IP address, or the Internet Protocol address. We need this address to connect our software on the laptop so we can delegate different seats, or set up our logo, or change any of the settings. First thing you need to make sure of is that your Wi-Fi is off. We turn this off because we need to connect to a network over Ethernet. To do that, you have to make sure your IP address is correct. In Windows, you'll go to your network and internet settings. Under Ethernet, the IP address will usually be set to automatic DHCP. We want to change this from automatic to manual using the IP version 4 protocol. We will type in the IP address that we want to use. This is not the same as the IP address on the receiver. It is a different one. However, it remains the same for the first 3 digits of the IP address, so 192.168.1 in our case. The subnet mask will also have to be set as well, usually 255.255.255.0. Some devices do not need an IP address, but rather can be set to an automatic DHCP. This will mainly depend on the manufacturer, or it will depend on the device. Once everything is set, we can go into a web browser of any sort and then type in the IP address of the receiver. In our case, 192.168.1.250. It brings up the login screen. We will then log in to our receiver by typing in the password, and this will log us into the main menu. Here we will see the 2 devices we set up earlier. These devices are shown as online devices. We will also be able to see the offline devices and the unregistered devices. If we go into the audio settings, we can see the active microphone settings. Currently, both microphones are not active. Therefore, they are not going to be seen here. However, there are some settings like high-pass filters, faders, and gain control. Even though the devices are not active, we can go into the input, and we can see at the top the analog in and the Dante devices if we are using this via Dante. We are using analog in as shown earlier, and here you can select if it's a line signal or an auxiliary signal. You can also check the high pass and low pass filters, and you can also see the gain input of the active devices. In our case, this is set to 0. On the Output tab, we can now see the analog output. This is currently set to -21, but we can adjust this by pressing the plus or minus button. This will be sent to the channel 3 that we set up earlier, and all the microphones will be outputted to that channel on the mixing desk. Under Meeting Controls, we can see even more settings. Here we can see if the speak mode is automatic, the maximum number of active speakers at any given time, or the maximum amount of delegates that can speak at any time. If we go under the tab Custom Welcome Screen, we can also set our logo here. Keep in mind that the logo must be exactly the right pixel size and the right format, which is PNG in our case. Now we have finished most of the inputting of our microphones, and now we can look at the output. Here we have a D&B Audio Technique D12 amplifier. A slightly older unit, but it still does the job. It has a power button, a control knob, and a couple of LEDs. If we turn on the amplifier, the 2 LEDs light up and the screen turns on. These LEDs are our mute switches, which we can use to mute the amplifiers when we want to test the system without any sound. And you can also see on the main menu that we have the speaker selection. At the moment, it's set to the C7 sub. We want to change this. So in order for us to change this, we have to go into the menu. What you do is you hold down the control button and it goes into the menu of the amplifier. In the menu, we have lots of different functions. Our main goal here is to set the correct speaker. You can set the input routing or the output routing. But in our case, we want to go to the channels. In here, we have channel A and channel B for the 2 different inputs. If we go into channel A, we can now scroll down and see the speaker selection. In our case, we have a set of D&B Audio Technique E8s currently set up for our output. So we change on the amplifier the speaker selection to E8s. We will select E8 and then we will confirm it by going OK. We have other settings that we can configure in here as well. For example, we have a cut, which will put on a high-pass filter. We also have a HFA, or high-frequency attenuator, to shelf high frequencies down slightly. Whether we want to use them or not will depend on the type of event that we are doing. In our case, we're doing a video conference. So we don't need a high-frequency attenuator, but a low cut would not be a bad idea. We will now repeat this process on channel B on the amplifier. We'll set the speaker to a E8 again, and then we'll put on the high-pass filter. On a side note, you'll see above the D12 there are 2 speak-ons. Those are the outputs to the E8s. And of course we have the XLRs, which is where we'll get our input signal from the mixing desk. And on the right-hand side we have a power con. Once we have set up our speakers, we can then test the audio to see how much output we want to have. In our case, we don't really know, so we'll just set the gain to 0. In any event, the objective is to get a good balance between our subwoofers and our top speakers. Once we are happy with the routing and the setup on the amplifier, we can now start testing. We will unmute the amplifier, and then we'll go to the mixer and test the audio and make adjustments. Here we have our two E8s. Both the amp and the speakers are made by D&B. Most professional audio equipment for live works in tandem, which means we have to match the amp to the speaker. This is called an E8 because it has an 8-inch speaker. There are two screws, one at the top and one at the bottom. We will unscrew these to see the inside of the speaker and look at the cone. D&B have a fairly unique property about their speakers. If we look inside of the grill of the speaker, we can adjust the cone by 90 degrees. Currently, we have the cone of our speaker angled horizontally, which we'll discuss in a moment. Here we can see our 8-inch speaker and the sound port. If we flip the cone 90 degrees, it is now in a vertical position. This will give you more distance, but less width. Having it at 90 degrees will give you more width, but slightly less distance. Then we put the grill back on and screw it back together. Here we have our mixing desk. It is a Yamaha DM3 portable digital audio console. This desk has already been set up, but we can go through some properties to make your workflow easier. When you start up the console, it will show the previous session that you were working on. The green LEDs that I'm pressing are the selection buttons, where you can select channels to do adjustments. However, we want to begin our session from scratch. So what we'll do, we'll go into our scene selection and recall our initial data. This will recall the desk back to the default settings that we set up when we received the desk. Press the home button to return to the main screen. And now we are ready to start our preparation for routing and mixing. You can press on the touchscreen, or you can press a selection button to select the channel you wish to work with. And now we can see if signal is coming in through our microphone. I'm currently speaking through a headset microphone that is connected to our Shure wireless transmitter in channel 1. Now we can do some customization. What I like to do, and what we like to do in general, is to customize the channels according to what signal we are receiving. The gain button at the top here will show us how much gain is being inputted into the system, which is currently 0, even though we have signal. But we don't want to deal with this now. We want to go to the bottom left of the channel and select the customization. This will allow us to change certain properties of the channel. We would like to rename this channel to a different name. This is of course subjective to the person that is running or operating the event. In this case, I'm just going to call it Mic 1, as it's channel 1 of our wireless microphones, which is plugged into the back of the console in channel 1. And we'll do the same thing for Mic 2, which is channel 2 of our Shure wireless microphones. And this is also plugged in channel 2 at the back of the mixing console. In this case, we're just going to assume that these two microphones are the same kind of microphone. Next thing, we can go to channel 3 and change the color to something else. The reason I do this is because now we are using a different microphone. Channel 3 is where we plugged in the wireless conference microphones, and we'll treat them differently. You could name this whatever you want, but just in this case, I know this is the wireless conference system, so I am just going to call this wireless. Now that is renamed correctly, we can press the home screen button, and now we can go about routing things correctly. For me, I very rarely have my channels go directly out the stereo master, and there's reasons for this that we'll get into later. So what I'll do, I'll turn the stereo out of these channels off. Make sure to do all of them, because if you don't, you're going to have a duplicate signal, one out the stereo and one out the mix. This is all done on the input selection, which is on this green LED. But now we want to look at the output channels and change the output on here. On the output channels, we can see the 6 mixers, 2 matrices, and the stereo out. We're going to go into mix 1. This is usually reserved for a stage monitor, but in this case we are going to use it as a group. We'll press the Send From button to see where we're going to get signal from. In this case, we want to get it from mic 1 and mic 2 because these are our two wireless microphones. Again, I will customize these groups for easy access and to know exactly what they are. So we will rename this mix, or this group now, to a new name. And usually when I do mixes or groups, I will make it the name of the device I'm using followed by mix. So in this case, mic mix. And for the conference microphones, it'll be wireless mix. Now you might think it's a bit of a strange thing to send a single channel to a group. The reason for this is because the group channels are used for feedback removal. And different microphones have different feedback responses, depending on the microphone and the gain and the frequency response. The reason we use groups is because the channels themselves do not have graphic EQs built into them. Only the group channels do. Now that the routing is complete, we can now begin with basic mixing principles. But before we do this, we are looking at channel 1. Let's go to the output and do a little bit of pre-processing before we start doing gain structure. What I mean by this is that we can go into our parametric EQ and change the first band to a high-pass filter. And now we can filter out to about 160 Hz to start off with. Why 160 Hz? In a studio this might seem like a very drastic cut, but in a live event this will be absolutely fine and you won't get too much low frequencies removed. This will allow us to increase the amount of gain that we would normally have for a stronger signal. The first thing to do is to set our gain level. There are several ways to do this. The most common way is to use our PFL. On a Yamaha console, this would be the Q button. PFL refers to pre-fader level, which we are able to listen to through our headphones and determine the correct gain amount. Now, of course, we saw signal coming into the channel, but we're not getting any output. And the reason for that is because we have to set the output of our mic mix into the stereo. And now sound will be coming out the stereo master. Let's return to the input channels and the mic gain specifically. Earlier I mentioned that you can turn the gain up and use the PFL or Q button to determine the amount of gain that you require. On a Yamaha console, the more you talk into a microphone, the more the indicator shows where your gain is supposed to be. This is arguably not the most accurate way to do it, because you might find that in the room that you're working in, you might need less gain or you might need more gain. It would depend on the sensitivity of your microphone and it depends on the size of your room. So as the classic saying goes, use your ears to determine this. Once your gain's complete, it is now time to do the ringing of your speakers. So for me, I'll keep my faders at 0 on the input channels. For both microphones, this will be the optimal level that I want to use. I'll have the gain on both microphones the same because in our case, they are the same kind of microphone. Then I'll go to the output channels and I'll make the stereo master 0. Most of the time, I do not change the stereo out because I don't want to affect the global output of everything. So my stereo output fader is all the way up and my input channels are all the way up. The only thing that is changing is the group channel. This is when I start to use the graphic equalizer. This will show all the different bands that I can use to cut out ugly frequencies and ring out our system. To do this, I will slowly bring up our group fader until it begins to ring. The ring I refer to is feedback, and you don't want any feedback in your system. This is why we call it ringing out feedback. And as soon as I start to hear feedback, I can then determine what frequency it is, either by listening or by looking at the RTA, real-time analysis, on the screen. This is when I will cut out frequencies that are feeding back. Usually I'll directly cut out that main frequency that is feeding back, and then do minor cuts around the frequency that is feeding back. Usual hotspots for feedback is around 800 Hz and 630 Hz for your low mids. And then for your high mids, it can be anywhere between 2 and 8 kilohertz. You'll slowly push up your output fader until you get to the optimal signal of the room. Keep in mind that the louder you go, every frequency will start to feedback. So you must really determine the loudness that you require for the event that you are operating. We have now wrung out all the frequencies that we don't want in our system. But our interface is looking a bit messy. We have a laptop over here that has 2 channels, left and right. If we hold down both of the selection buttons at the same time, we can stereo link these 2 tracks as left and right, which can be controlled with one fader. These 3 channels here are not being used, so it would be better for us to use a custom fader. In the settings, we go to Custom Fader Setup, and then we can choose in Custom Fader 1 what we want in the custom fader. I like to put into my custom fader the most amount of information that I can. I will have channel 1, channel 2, channel 3, and then I can remove channel 4, 5, and 6 because I'm not using them. And then I can also have the laptop, but I don't need both faders in my custom fader set because they are stereo linked. Therefore, I only need one because one fader will affect the other. Now more spaces have become available, which I can use to add other information that I'd rather have. In this case, the mixes or our groups. So all of my output and input channels are all on one custom fader set. Doing this gives us an advantage. We can now do our mixing, EQ, compression, and so on, either on the input channel or the output channel, without having to change tabs from input to output. The last feature we use on the Yamaha DM3, if you have the version 3 firmware update, is the Automixer. Not to complicate things, but the Automixer does not automatically mix your music. What it is essentially an auto gate function. You can set it on the first 8 channels of the DM3, on each of the channels that you would like to use it on. What it does is essentially gates the signal coming in from that channel when a threshold is below a certain point. It is probably not the best idea to use it on the conference microphones as different people will be using these and it's only over one channel. But if you use them on the wireless microphones, for example, it will clean up your signal and you won't have excess bleed coming from other microphones. A very useful tool to have cleaner signal and to eliminate possible feedback that may occur with multiple microphones. Now you can't have a video conference without video. Here we have 2 laptops. The first one is the one we set up our audio on, but we've now unplugged the Ethernet cable and replaced it with the Blackmagic controller, which we will discuss a bit later. During a video conference, we generally have PowerPoint presentations or a video feed coming from an online provider such as WebEx or Zoom. Whether it's a PowerPoint or a Zoom call or such, you still need to have audio. And to get audio from a laptop, you have to use an audio adapter. In this case, we generally like to use a 3.5mm jack going into an XLR out. Simply plug in the adapter into the audio output of the laptop, and then plug in the XLR cables into your mixing desk in the free channels. But keep in mind, if you're using something like WebEx, you have to ensure that the driver used for audio on WebEx is the device that you are using. This does not only apply to the one laptop, but for both. So you'll need 2 audio adapters, one for this one and one for the other one. You have to have 2 laptops if you're running presentations to make smooth transitions from one to the other using the Blackmagic. And this is the Blackmagic I am referring to, called the Atem Mini Pro. We have one output source, which is the main screen as you can see, and we have 3 input sources, laptop 1, laptop 2, and our streaming camera. When you set up, make sure the resolution and the aspect ratio is the same for all devices. In the software provided by Blackmagic, you can change the different features, such as fade length or layering different displays on top of each other. Now, if you look at the Blackmagic, you can see multiple cables plugged in. Those 3 cables are our input channels coming from the camera and the laptops. Let's take a closer look at what we are dealing with. Here we have our power, our Ethernet going into our laptop, which controls the software, and we have a USB, and this USB is plugged into an external hard drive that we use to record the entire conference if requested by the client. We have one HDMI that is sending out to our main display. And then we have an audio source, which is controlled by this red button over here. Make sure it is on. This audio is then plugged into our mixing desk, very much like the laptops. If you're using conferencing software like WebEx, you need to select the Blackmagic as the ASIO driver on a Windows computer, or the driver on a Mac computer.
That's it. Think I could say something else, but I don't know what else to say.
I hope they don't burn now.
What don't burn?
You see,
The motors. Oh, that sounds fun. What's that? Yay! It makes a noise. That's a good start.